For decades, terrible earthquake scenarios have been acted out in film, terrifying audiences with quakes that may destroy entire cities or bring down skyscrapers. If the big one strikes the west coast, those fictional movies will not remain fiction. A 6.4 magnitude earthquake struck Ridgecrest, California on July 4, 2019, followed by a 7.1 magnitude earthquake the following day. But none of these comes close to the anticipated big one, which is expected to finally jolt the Golden Coast according to scientists. To know about North America's imminent worst disaster, stay tuned until the end. Hello everybody, welcome back and greetings from the Space Venture. Here, we introduce you to the wonders of the cosmos. We give you exciting and enlightening information in cosmic statistics and facts. Therefore, subscribe to the channel and don't forget to click the bell icon to never miss an update. With that said, let's get started. While specialists can't predict with absolute certainty when a quake will happen, they do have a fair sense of where. We all know that California is situated in a hot zone of fault lines, the San Andreas Fault being the most well-known. The Pacific Plate and the North American Plate are separated by the San Andreas Fault. It divides California's in half between Cape Mendocino and the border with Mexico. The Pacific Plate is home to Big Sur, Los Angeles, and San Diego. On the North American Plate, there are San Francisco, Sacramento, and the Sierra Nevada. In addition, the San Andreas Fault does not pass through San Francisco, despite the famous city's 1906 earthquake. But because they are directed at the fault, places like the Desert Hot Springs, San Bernardino, Wrightwood, Palmdale, Gorman, Frazier Park, Daly City, Point Reyes Station, and Bodega Bay are vulnerable. The main myth surrounding the San Andreas Fault is that it will eventually crack and cause California to slip into the ocean. Do you think it is inevitable? Let's see. A seismic creep is a phenomenon that occurs on the well-known California fault between Parkfield and Hollister. The two sections of the fault move imperceptibly, releasing stress without creating significant earthquakes as opposed to building up the strain and slipping in one earth-shattering instant. Researchers have discovered that this portion of the fault may have had earthquakes of a magnitude of 7 or higher millions of years ago. That is bigger than the magnitude of 6.9 Loma Prieta earthquake, which struck the Bay Area in 1989 and killed 63 people. Although the exact timing of the massive earthquakes on the fault is unknown, Genevieve Coffey, an earthquake geologist at CNS Science in New Zealand, indicated that they took place within the last 3 million years. Geologists now forecast that the so-called Big One, a significant earthquake, will happen somewhere along the San Andreas Fault Line soon. While the San Andreas Line's northern position has had numerous earthquakes, the southern portion of the fault hasn't experienced a significant quake since 1857, when a magnitude 7.9 earthquake struck the mountains near Los Angeles. According to scientists, there is so much tension in the southern portion of the fault's rock formations that the Big One could occur soon. Major earthquakes have occurred more frequently in the Oakland Bay region, which is virtually directly over the San Andreas Fault. Because of the 7.8 earthquake that struck San Francisco in 1906, large portions of the city were destroyed and 3,000 people died. Another significant earthquake with a magnitude of 6.9 struck the area south of San Francisco in 1989. The Pacific Plate and the North American Plate are split apart by the San Andreas Fault. The two plates are passing each other at a rate of around 2 inches every year because continents on Earth are constantly migrating. At some point, the Earth's crustal tension will become too great and energy will be unleashed. Geologists believe that there is a good possibility and probability that tremors with a magnitude of 7 or 8 would strike Southern California at some point shortly, even though it is impossible to predict when an earthquake will strike a location. A sudden movement along the plates may start a chain reaction of movements. Los Angeles, the largest metropolis in California, is only 30 miles from the fault line and might sustain significant damage. According to studies, a significant earthquake can cause up to $200 billion in damage and over 2,000 fatalities. The San Andreas Fault typically ruptures every once 150 years. Over 200 years have passed since the fault's southern sections were last active. In Southern California, there hasn't really been a significant earthquake since 1857. In fact, the last time the contiguous US was hit by an earthquake with a magnitude greater than 8 was centuries ago. The most recent one to be recorded had a magnitude of 9 and it occurred in 1700s. Along the edges of subduction zones, the largest earthquakes ever recorded have occurred, and those are the locations where one tectonic plate is sinking beneath another. The biggest earthquake known to have occurred in the United States was near the Cascadia subduction zone, where the North American Plate and Juan de Fuca Plate are being subducted beneath one another, and because of the plate, we can have quite large earthquakes there. In other words, a significant shakeup is long overdue. The most likely scenario, according to a 2008 federal analysis, is a 7.8 magnitude earthquake that ruptures a 200-mile section along the fault's southernmost portion. Every time an earthquake occurs, it leaves behind telltale marks that over time become buried or etched into or onto outcrops, and other geologic formations. For instance, evidence of an old earthquake can be seen in fault scarps, offset and folded layers of sediment and soil, and areas of the landscape that have been tilted, lifted, or torn apart. Because lesser quakes rarely leave behind evidence, researchers often find only evidence for earthquakes greater than magnitude 6. Researchers can dig trenches along a fault to reveal what occurred. They can observe when and how frequently an earthquake occurred there within a trench. They count the number of previous earthquakes they can see and calculate the time interval between each earthquake. These figures enable them to calculate the recurrence interval or the typical interval between earthquakes at the same location along a fault. When event likelihoods are taken into account, the 97.5% confidence interval at the Southern Californian paleoseismic location of 1,000 pounds shifts from 455 years to 1431 years. The possibility that the data has been accurately interpreted as a particular earthquake is known as event likelihood. Every fault line has a maximum strength that is influenced by its length, width, and slippage capacity. The highest limit is around 8.2, which is a severe earthquake, but because the Richter scale is logarithmic, only 6% are as violent as the 2011 earthquake in Japan. The San Andreas is one of the most studied and best understood fault lines in the world, but there is another fault line that is located just next to the San Andreas. The Cascadia subduction zone extends 700 miles offshore to the Pacific Northwest, starting close to Cape Mendocino in California, moving across Oregon and Washington, and coming to a finish at Vancouver Island in Canada. The Cascade Range, a group of volcanic mountains that run parallel to one another about 100 miles inland, is where the Cascadia portion of the name originates. A tectonic plate is slipping underneath another in a region of the planet known as the subduction zone. The mantle and crustal plates known as tectonic plates are responsible for the movement of the Earth's continents and oceans throughout eons of time. They typically move in a sluggish, non-lethal, and nearly invisible manner. The trapped edge of North America is bulging upwards and compressing eastward under the weight of Juan de Fuca at rates of 3 to 4 millimeters and 30 to 40 millimeters per year respectively. As far as continents go, it is young and made of very elastic rock, so they can continue to do so for a considerable amount of time. But it can't continue doing that forever. The craton, that ancient immovable mass in the middle of the continent, serves as a backstop, and sooner or later, North America will bounce back like a spring. The magnitude of the subsequent earthquake will be between 8.0 and 8.6. If, on that occasion, only the southern portion of the Cascadia subduction zone breaks away. The big one is that seismologists refer to this as a full margin rupture if the entire zone breaks away all at once, in which case the magnitude will fall between 8.7 and 9.2. That is the big one. Really a big one. According to FEMA's projections, the Cascadia earthquake will result in roughly 13,000 fatalities. The organization anticipates that there will be an additional 27,000 injuries, and that it will be necessary to house 1 million people, displaced individuals, and give food and water to an additional 2.5 million. However, the time until the next significant earthquake is running out. Anyways, we've arrived at the end of the video. Feel free to express your thoughts in the comments below. If you loved the video, make sure to hit this like button. Also, don't forget to share and subscribe. In the next one, we'll see you again.